Hi, we're going to be talking about probability in this next section. And I'm going to use an example you're all very familiar with, I'm sure. Flipping a coin to describe or to illustrate some of the definitions and some of the different things we're going to do with calculating probabilities. Okay, so you know that when you toss a coin, there are two possible sides it can land on, the heads or the tails, right? So on a coin toss, you can either get a heads, which I'll call H, or tail, which I'll call T. All right? Now, there's a few definitions that I want to go over with respect to probability, and I'm going to use this idea of tossing a coin to illustrate the different aspects of those definitions. So the first thing is an outcome. Okay, so by definition, an outcome is an individual result of an experiment. In the case of a coin toss, this would be either a head or a tail. Okay, so there are two possible outcomes for a coin toss. In our case, two possible outcomes, H and T. Okay. Now, if you look at the total of all the possible outcomes together, we call that a sample space. Okay, so a sample space is the set of all possible outcomes of an experiment. Okay, it's the set of all possible outcomes of an experiment. Now with a set, we typically use a notation with these braces on either side. Okay, so a set of numbers or a set of events would be contained in this sort of notation. In our case, the heads and the tails are the two things that go in there. Okay, so the sample space, this would be the sample space. This is all the possible outcomes of a coin toss. Okay, if you were drawing a card from a deck of cards, you'd have 52 possible outcomes in the sample space. You'd have the ace of spades and the king of spades and the queen of spades and the jack of spades, and then you get through all the spades and you go to the hearts and the diamonds and the clubs and all that stuff, right? So you'd have 52 possible outcomes. Here there's only two possible outcomes. If you roll a dice, there are 6 possible outcomes. Okay. And then finally, an event. An event is some it says some of the outcomes from a sample space. Some would call this a subset of the sample space. Okay. It's not maybe such a good illustration to use a coin toss for an event, but let's just assume now maybe that that you were to toss a coin, 2 different times. So you do two coin tosses. All right. In that case, you would start out with either the first coin toss. I keep wanting to say coin toss. That's not right. The first coin toss, let's do 2 tosses. The first one would either be a head or a tail. Okay, just depends on how that turns out. The second one would then also either be a head or a tail. So either you do head and then a head, or a head and then a tail, or it could be a tail and then a head, or a tail and then a tail. Okay, so there's really 4 possible outcomes. And when you combine all of these, you can get the sample space and different possible events. So let's look at this. The sample space would be all the possible outcomes. Okay, so in our case it'd be head head. That's the possible outcome. Head tail is a possible outcome. Tail head and tail tail. Okay. Those are all the possible outcomes. There are 4 of them for the sample space. Now an event could be any subset of those outcomes, any collection of them. You could have, for example, an event, and I'll just make one up here, maybe at least 1 head. Okay, so the event then is at least 1 head, meaning as long as there's a head that comes up, it's listed in that event. So head head, head tail, tail head are all in that event. Tail tail would not be something included. So this is what we call a subset, because it's another set of some of the outcomes from the sample space. Okay. Now, to give you an idea of how this is useful with probabilities, the probability of any event is the number of outcomes in the event divided by the number of outcomes in the sample space. Okay, so let's look at that definition. The probability of event is equal to the number of outcomes in event, or in the event, I'm skipping some words here, divided by the number of outcomes in the sample space. So the total number of outcomes, right? So in this particular case here, this example I just wrote down, the probability of at least 1 head, and that notation we usually use a P and then the event described in parentheses. Probability of at least 1 head is equal to the number of outcomes in that event, which would be 3, divided by the number of outcomes in the sample space, which is 4. So the probability is 3/4. You can list probabilities in fraction form, or you can list them in decimal form, or as a percentage. And I would accept really any of them, although I'm thinking the fractions are going to be the most commonly accepted one on your Hawks homework. But you could also write that as 0.75, that's a probability in decimal form, or 75% if it was in percent form.